Welcome everyone to Virtual Planetarium for May 2023, and we will start, as we always do, with the inner solar system. And Mercury is very quick because it's at inferior conjunction on the 1st of May, so not visible.
No, not really. It shines at magnitude plus 0.5 at the end of May, but it only rises 40 minutes before the sun, so it's not really viable, is it? Venus has been a magnificent planet, visible after sunset over towards the west and the northwest. Now is a good time to have a look at it, because as we head through into June, it will start to degrade in position quite rapidly.
It will. They'll close up and then be gone before we know it. It's amazing how quickly Venus disappears, actually, once it starts. Once we get past greatest elongation, the point where it's the furthest separated from the sun,
Yes.
It starts to fall back to the sun rather rapidly. So, yes, definitely worth doing. On the 9th of May, Venus will be about magnitude minus 4.1 and sitting 1.8 degrees to the north of the open cluster M35 in Gemini. But you'll need a flat horizon to see that encounter, though, because the pair are going to be quite low down when darkness falls.
Yeah, that is going to be a very tricky thing to observe. On the 16th of May, Venus sits 3/4 of a degree from Mabsuta, which is Epsilon Geminorum. All the while, the period when you're able to see Venus against the dark sky will be shrinking and the planet's altitude decreasing after sunset. Through a telescope in the middle of May, it's about 60% lit and the disk is about 20 arc seconds across on that date. So you're into observing Venus at that sort of size and that phase. What can people look forward to seeing?
Well, it's actually a very interesting part of the phase because at that point you can see the coverings over the polar regions, the cusp collars, these and the cusp caps. The cusp caps are bright patches over the north and south pole, and they're bordered by these sort of darker, hazier cusp collars. And they're not constant. Sometimes one's bigger than the other, sometimes one's brighter than the other, sometimes neither of them are there, and we don't really know why. There's also markings on the clouds, these striped sort of markings that you can see.
Oh, yes.
If you've got... And if you're sensitive to the bluer end of the spectrum, if you can find it easier to see bluer light than red, then you will see these details easier. There's also the bright limb band as well that can be very brilliant. But if you're looking in infrared, as in observing with a filter, it's not something our eyes can see naturally, then we have seen this, what's called wave discontinuity. That's this very unusual, very strange linear feature going north-south across the planet's equator. And that has been cited quite frequently and only turns up in infrared images. It's very unusual, and we still don't have a full explanation to why that's what causes it and why it appears and why it's not always there. So
in order to get
lots to see.
Yeah, so in order to get that, you need an infrared pass filter plus an infrared sensitive camera, and just make sure that your infrared sensitive camera or your camera hasn't got an infrared blocking filter on it.
No.
Because if you do that, you won't see anything at all.
That's right. I tend to observe Venus during the daytime or during twilight because the cloud, even at 60%, the dazzling glare from the cloud tops will wipe out all of the features.
Yes.
So, but you might also try, if you've got a yellow filter, these are the optical filters that come with most telescopes. If you put a yellow filter on, that really helps reduce the glare and helps to bring out some of the cloud markings as well.
Very good tip. And of course, if you're imaging during the day using an infrared pass filter, that helps to darken the blue sky. So Venus stands out really well with the camera. It's a great way of doing it. Well, Venus's monthly visit from the moon is a 2-evening affair this month. The MAG minus 4.1 planet will have a visit from a 10% lit waxing crescent moon, 6.8 degrees to the right and slightly below it on the evening of the 22nd of May. And as a 17% lit waxing crescent 4.8 degrees west, that's above and to the left, of it on the evening of the 23rd.
On the 31st of May, the bright evening twilight starts to win against Venus. It's no longer possible to see the planet against truly dark skies from the UK. And on the 31st of May, Venus sets 3 hours and 30 minutes after the sun. It's a shame about that, actually, because in order to try and see the fairly controversial ashen light, or not as controversial as it used to be, you do need a fairly dark sky. So it will be a tough thing to do to see towards the end of the month from the UK. But Southern Hemisphere observers, of course, Venus will be getting higher and very well placed.
How convenient that it's not well placed to see the ashen light.
Well, it will be well placed for people in the south, won't it, Pete? So it's not being hidden from view. It's just the people in the south will have a better view. So I wrote a recent article. It's a shameless plug. I wrote a recent article on the ashen light. I think there might be something more to it than we originally thought. So.
I'm very sceptical, as you know, because the problem is that in order to confirm it's there, you have to get an image of it, basically.
Yeah, that's true, but it is a fact that most people have stopped imaging by this point in the run because Venus is very low, and the NASA spacecraft that recorded strong surface details on the night side of Venus in wavelengths, infrared wavelengths that are visible to the human eyes was quite compelling. So one could imagine the atmosphere thinning a little and the surface being glimpsed, and that would be accessible from Earth. So this is something people are now considering. But what we really need is someone to see it and image it at the same time.
Well, that's it. And it hasn't happened yet. That's why I have a degree of skepticism about it. But I'm happy to be proved wrong. I'd love to be proved wrong. But
skepticism is fine. It's when people are fixed in a position that isn't terribly helpful.
Yes, that's right. Okay, well, let's go beyond the Earth now, out to Mars. And Mars is, well, it's quite dim, actually. It's for Mars, I would say. Mars is a MAG plus 1.3 evening planet in the constellation of Gemini at the beginning of the month. And throughout the month, it'll lose altitude as darkness falls. On the evening of the 23rd of May, magnitude plus 1.5 Mars, so it's fading very slowly throughout the month, will lie 14.5 degrees to the west of mag minus 4.1 Venus. So Venus is a good way to find Mars on that date. And there will be a beautiful 17% lit waxing crescent moon sitting between both planets.
Yeah, it's a shame now. Mars is still hanging around. It's actually not badly placed for observation.
No, it's not.
But for the fact that it's so small now, it's really quite a challenge to see anything on it on the disk, and quite a challenge to pull out details in images now. It's a non-trivial thing to observe. On the following evening, the 25% lit waxing crescent moon sits 3.2 degrees above Mars, and both will be near the Beehive cluster. That's M44 at this time. But the late twilight and the low altitude will make the Beehive cluster quite hard to see, I think.
Yeah. Okay. Well, on the 31st of May, it's worth noting that MAG 1.6 Mars will be knocking on the western side of M44. But the cluster stars, as Paul said, will be really hard to see due to low altitude and bright twilight. Make a good challenge to try and capture that, actually.
It will. And by the end of May, Mars is just 4 arc seconds across. And that's probably where I will stop for Mars, this current apparition, because it is quite small by that point.
Yes, it is.
All right. Well, let's move out to the giant planets now, Jupiter. So Jupiter was at conjunction with the Sun last month, so it's in the morning sky but isn't really very well placed. No. And really your best chance of spotting it are in the early morning dawn twilight. It's low above the east-northeast horizon by the end of the month, but kind of really out of the way for the moment.
Yeah, there is a special event actually with Jupiter which happens on the 17th of May, and if there are various ways to capture this, and you can find additional information in the magazine. But basically on the 17th of May there will be a lunar occultation of Jupiter which occurs during the day. Now, you can see Jupiter during the day. It's a bit ghostly. It's not like its nighttime appearance at all. And the moon will only be 7% lit, so that's going to be quite tricky to pick up during the day as well. But it's such a rare event that it is worth looking out for. There is another catch, because in order to actually see the occultation, you're going to have to go north of the border into Scotland and the far north of Northern Ireland. They can see it as well. But from more southern latitudes, you will see a really close pass of Jupiter as the moon zips across to the north of it. And that's worth looking out for if you've got clear blue skies.
Yeah, and finding the moon is much easier than finding Jupiter. So in the daytime sky, so it's a useful thing to be able to have. Moving out, Saturn, similar sort of picture really. It's a morning object, but the dawn, twilight, and low altitude mean it's really not very well placed at all. So the end of the month will be a good time to try and spot it. And Uranus, not visible this month. It's actually at conjunction with the Sun on the 9th of May, so not visible. And Neptune, likewise, morning object, but really lost in the dawn twilight. So we can regard Uranus and Neptune as gone this month.
Yes, okay. Well, we've got a few special events. On the 11th, we've got lunar libration and phase favouring the northern polar regions of the moon. And that's a good opportunity to look out for rarely seen features such as Hermite, which is a crater which sort of comes into view and then disappears again. We've got also later on in the month, lunar libration and phase will favour a view of the impressive 207-kilometre crater Humboldt on the evening of the 21st of May. That's really something to look out for because Humboldt's quite impressive, isn't it?
It is quite impressive. It's so rare that it's visible that I have no drawings of it at all.
Really?
I've only seen it a couple of times. Well, if you think about it, the libration, as you say, Pete, has to favour when it's on the disk. Combine that with it at a reasonable altitude and a clear sky, it's actually quite tough to see.
It's the combination of libration and phase that is the key, isn't it? Because you need to have if the phase is such that Humboldt is fully lit, you don't get any relief features with it, so it sort of merges in with the background. I mean, there are dark patches inside the crater which make it stand out, but it's better if the phase favours it. I was very fortunate. I caught it a number of years ago under extremely good seeing. It was an incredible evening, actually. I do remember it very clearly, as you do tend to do when you get good seeing. But one thing I do remember from that evening is that there was an aircraft that went past nearby, and the vapor trail from that, which was transparent, there was no sort of vapor there to see, but it rolled over the moon, and it was like a cylindrical lens magnifying bits of the moon as it rolled over it. Quite incredible.
Quite an unusual effect, actually. I don't think I've ever seen that here. I've seen planes and things go in front of the moon before, and modern aircraft are quite bright when they go in front of your eyepiece. They are quite startling, make you jump.
Oh, they do make you jump, yeah. Okay, well, on the 22nd, we're getting to the point where noctilucent clouds are coming back into to view, and I wonder what this year's noctilucent cloud season holds for us.
Yes, every year is slightly different. Some years we have really magnificent displays, other years very little. So there's no real way of predicting it, at least not as far as I've seen. So we'll just have to wait and see. And hopefully we get some nice displays of these noctilucent clouds.
Yes.
On the 23rd, we have the 14% lit waxing crescent moon passing 1.7 degrees north of Venus during the daylight hours. Closest approach actually occurs in the morning at 11:20 UT. So to find that, you should be able to see the moon during the day. That's not too difficult, and you can use that to find Venus.
Yeah, it's quite good actually, because you can see Venus with the naked eye when that happens, if you can pick up the moon. On the 27th, actually it's the 27th and the 29th, isn't it? We've got a couple of clear obscure effects. On the 27th, we've got an effect known as the stars of Aristillus, which is basically where it's a complex mountain peak inside the crater Aristillus, and the light of the lunar dawn hits the top of those peaks, creating what looks like a little star cluster in the middle of the crater. It's very attractive.
It's very, very attractive, very, very distinctive. And if you're not expecting it, it looks very, very unusual.
Yes, it does.
But it is certainly a very nice clair-obscur effect. On the 29th, the jeweled-handled clair-obscur effect is also visible in the evening. And something of interesting to note, on the 30th, if we start to view Venus now through a telescope, it appears to be approaching 50% illumination. Now, we say appears because actually Venus is scheduled to reach precise 50% illumination in early June, I think June the 4th. But Venus will reach 50% illumination before that date because of an effect known as the phase anomaly or the Schroter effect. So if you start looking at Venus on this date, you'll find that it's very, very close to 50% illumination and actually hits 50% illumination before it's predicted to.
Yeah, that's good. That's a good thing to try and observe. Okay, well, let's now go out to the night sky then, which is shrinking quite noticeably throughout May. Certainly by the end of May, we've got very little, have we? It's just the twilight to twilight with a little bit of darkness in between. But the main standout star, I guess, at this time of year is the bright orange star Arcturus Alpha Bootis, which is very evident. And that sits at the southern pointed end of a large kite-shaped asterism, which is Boötes the herdsman. Now, Boötes is not known for deep sky objects. I can't actually think of many in there. I can't think of any in there at all.
No.
It's a bit of a void in terms of that. But there are some beautiful double stars in Boötes, which are worth looking out for. Have you observed any of these?
Yes, I have actually. I have observed Isar, Epsilon Bootis.
Yes.
This is an unequal magnitude pair. We got 2.6 and 4.8 magnitude, separated by just 2.9 arc seconds. So you need a 75 millimeters telescope or larger to split them. And they are quite distinctive in color. You've got a sort of golden yellow one and a blue one, which is always an attractive pairing.
Yes, it is.
And Kappa Bootis, this is separated by 13.5 arc seconds. And again, two components, one at magnitude 4.6, the other at magnitude 6.6. So they're quite pretty. They're the two that I've looked at the most.
Yeah, well, there are some others in there. There's Delta Bootis, which is very easy if you're not into double star observing. This is a mag plus 3.6 and plus 7.9 pairs, separated by 103.8 arc seconds. We've also got Pi Bootis, which is a bit trickier. Pi Bootis is a lovely tight double star with component magnitudes of plus 4.9 and 5.8, separated by 5.5 arc seconds. There's another one actually, which is Xi Bootis, which is shows us a yellow and orange pairing of mag plus 4.8 and plus 7.0 stars, separated by 6.3 arc seconds. Now that's slightly wider than Pi, but there's a bigger difference between the magnitudes of the components, and that makes it harder, doesn't it?
It does, can make it harder to see. We also have 39 Bootis, a little tighter, 2.7 arc seconds, but easy to split. Companions of similar brightness, actually. They've got magnitude 6.3 and 6.7.
Yeah.
And then 44 Bootis, a good binary to test your optics. Now, this is an interesting one because the components reached a minimum separation in its 210-year orbit of 0.2 arc seconds in 2020. And the current separation is, it's 0.4 arc seconds?
About that, yeah.
Right, so it's magnitude 4.8 and 6.1, so they're quite close together. And I guess it's going to look more like a peanut shape than be resolved into two components in some telescopes.
Yeah, and it'll be at the mercy of the seeing, of course. The seeing will, if the seeing is poor, it'll just make it look like a single star, really, just sort of morphing in shape. But yeah, interesting to have a look at 44 Bootis, but don't expect to see them well split at all. We've got a similar issue affecting Zeta Bootis, actually. The components are well matched at mag plus 4.5 and plus 4.6, but the separation shows them as a star sort of joined together, really. It's really, really close. But I think my favourite has got to be Mu Bootis, mainly because of its name, which is Alcalurops.
An excellent
Fabulous. It is an excellent name. And that's quite wide, with magnitude components of plus 4.3 and plus 6.7. They're separated by 107 arc seconds. And the dimmer component is double again. Similar brightnesses, actually, for this one, plus 7.1, plus 7.6. But they are separated by an eye-wateringly close 2.2 arc seconds.
That is very close, but still worth having a go. Well, east of Borealis is a very pretty compact constellation, Corona Borealis,
Oh, yeah.
the Northern Crown, which is I think it's really unmistakable.
It is, yes.
I think it's actually, Pete, I think it's one of the constellations that when I first started out, after the Plough and Orion, I found very easy to identify.
Yeah.
Because it's quite compact and it's a very distinct little group semicircle of stars.
It's a beauty, really is a beauty. And it's got that one which is slightly brighter than the rest, which is Gemma. It's got another name, isn't it? Is it Alphecca?
I believe so, yes.
Yeah, which is Alpha Coroni Borealis, which is the jewel in the crown, basically. But it is very distinctive, as you say. And actually, it's quite a useful area of sky, because if you look in the middle of the semicircle, you normally wouldn't see anything at all. But there can be a star there, which is R Coroni, which is a variable star. It's a carbon star that puffs out sooty clouds, basically, that coalesce into soot, and they block the star's light and make it disappear. But it's irregular in terms of its variability, so you're never quite sure when it's going to be there and when it's not there. So that's well worth looking out for, really.
And it's quite pretty as well. I find with these carbon stars, when they're kind of halfway between their maximum and minimum brightness, that's when the colour tends to really stand out for me. And they really are shockingly red. They are quite unmistakable.
Yes, they are.
And it's an interesting thing, I have to really be careful. I do a number of variable star observations, and I have a number of carbon stars that I follow. And because I'm so biased, because I think they're so pretty, I have to defocus the telescope slightly so that it doesn't bias my visual magnitude estimates. It's a common problem. It's not just me. Because they're so striking in the telescopic field, one tends to, be put off a bit by estimating their brightness. But if you slightly defocus the telescope, then it makes it slightly easier.
Which way are you biased then? Do you estimate them brighter?
I do. I think it's some sort of bias that makes them appear more important and impressive than they are. I think that must be what it is. It's not by much, but it's a consistent amount each time, and I have to be very careful when I do it. So much so that I when I prioritise what I'm going to observe in the evening, I tend to do the carbon stars last and one after another, so that I'm not switching back and forth between ordinary coloured stars and red stars. So that really reduces it.
Okay.
Just a little tip if anyone's thinking of following carbon stars.
Yes. Okay. Well, to the southeast of Corona Borealis is the zigzag shape of Serpens the Serpent. The Serpens is unique in the heavens in that it's split in two, and the head is represented by Serpens caput and the tail by Serpens cauda. Serpens is carried across the sky by the constellation of Fucus, the serpent bearer, obviously. And it's Serpens caput that lies to the west of Ophiuchus and southeast of Corona Borealis. But it's in this little bit of Serpens where you've got, I think it's the best globular cluster, one of the best globular clusters anyway, which is Messier 5, which sits very conveniently right next to the star 5 Serpentis. So you go from 5 Serpentis to find M5. So it's all the 5s.
I think you say that about every globular cluster. I think you can't distinguish between. You like them all. So I have actually seen M5. I'm going to confess up. I did see M5 once by accident. I was actually looking for something completely different, so I stumbled across it. It is actually quite a beautiful globular cluster, especially at low power.
Yeah.
And I thought, I can't remember what globular cluster is that, so I fired up the star charts and there it was, M5. I think I might even have been looking for 5 Serpentis, actually. So, it's definitely it's a definitely good way of finding it, but I only saw it once by accident, but definitely worth a look.
Okay. Now, one way to locate M5 is to use the constellation of Libra, the Scales, which lies to the south. The 2 brightest stars in Libra are... You're going to get me to say this, aren't you?
No, I don't have to get you to say it, because you say it every time because you love the names of them. But go on.
Zubin el-Janubi, which is Alpha Libri, and Zubin el-Shamali, which is Beta. And they form as I always describe it, a 45-degree line in the sky, which
45-degree
which
line.
is crazy because there's only two stars, and But although that description seems vague, the lack of much else around it makes it work really. And if you imagine Zubin el-Shamali as the centre of a three-pronged steering wheel, with Zubin el-Janubi as the star at the end of the bottom left spoke, M5 would be just to the north, where you'd imagine the top end to be. Top end of the spoke, of the upper spoke.
Yeah.
Does that make sense?
No, I think you see what you want to see. Anyone who can make a 45-degree line out of two stars, well, there we are.
Excellent. Okay.
There is plenty to see in the night sky, though, and at the time that we are recording this, we have had wall-to-wall cloud for seems like forever, so I'm hoping that May will be much better.
Absolutely. Thanks, Paul.
Thanks, Pete.